So we're doing inductors now, RC circuits, right? We're inductor resistor circuits for transient analysis, and I gave you a bunch of questions, and I think I answered some on one. But do you have any problems you'd like to do? Yeah.
344.
4?
344.
40. Didn't ask this, but anything going on around campus besides rain?
There's a career fair.
There's a career fair.
Career fair when?
In like an hour.
Today?
It's going now, yeah.
Oh, it is? Okay, all right. Is that where some of the people in here are?
Probably.
That would make sense. Where is it?
Ground level.
Brown Club? Okay.
There's also an online.
All right, 344. These are problems that, you know, they make sure that you understand the basics. If you do, you'll be fine. But if you don't, it really exposes areas of weakness. And, that's what all these problems do very well. So for here, all right, this one has two switches that change state at t equals 0. And I put in that IL, it wasn't there. I'm going to tell you this much. Anytime you have an inductor, which this is, and a resistor for transient problems, if there is no defined current for inductor, I generally speaking define it going from left to right, from top to bottom as positive. You with me? Now, what they're asking, the I naught of t and V naught of t, you worry about after you find the current for t greater than 0 through the inductor. Do you all follow me on that? The only thing we care about is this, IL of t. The rest of the stuff we get later. So we know for transient analysis, IL of t will be some unknown constant, possibly, t over tau plus k2. We know that. We know tau is equal to L over R Thevenin, where R Thevenin would be across the inductor after the switch closes. And it is the Thevenin equivalent resistance across the inductor as if the inductor was a load. So we're going to do this, and we always start at t less than 0. Okay? So for t less than 0, the switches are on. They're closed. Well, I'll do it over here. So for t less than 0, I want you to just look at this. That switch is closed, right? The resistor is still there. That inductor is replaced by a short circuit, right? A wire, right? That's still there. That's there. That's replaced by a short. So here's what the circuit looks like in a nutshell. I have 12 volts over here. Then I have 4 ohms, right? 4 ohms down. here's my inductor, and I'm gonna replace it with just a short. This is what I'm after, right, that current. Then I have 6 ohms. And 2 ohms and 6 volts. That's 6 volts. Y'all, can y'all see it, people? All right. I want that current. How are you going to get that current? Now, there's so many ways, right? Yeah, that's what I would do. All right, how many understand that source transform? Probably going to make this a lot easier in a heartbeat. All right. Now, listen to me carefully. You can't transform this. Y'all follow me? This little thing right here is what we're after, so we can't transform. Okay. So what am I going to do? Well, I have the 4 in series with 12. I'll transform that to 3 amps in parallel with 4. Do y'all see that, class? So this part of the circuit becomes, this is going to be 3 amps, and then it's in parallel with 4 ohms. That's this 4 ohm right here, and then I put it in parallel with this 4 ohm as well. I'm right there. Y'all see it? I want to make sure you see it. Yes. Did you? Y'all with me on this? Can you see it, class? And the far back, can you see this? Way back there? And way back. All right. What is my next step? Stick on this side for now. What am I going to do, class? Combine the 2 4s into 2 ohms, right? They're in parallel, so 2 ohms. So, I make this 2. All right. Remember, this is where I'm going to replace it, right here. Follow me on that, class? I put the cuts right here. Now, you can do it a couple different ways. What I'd suggest now, go ahead and transform it back to a voltage source in series with the current. It'll be easier to see, all right? When I do that, I'm going to have what? 6 volts in series with 2 ohms, correct, class? I want to make sure you all see it. Far back, you all hear me okay? This will be 2 times 3 is 6 volts in series with 2 ohms, right? So this will be equivalent to plus to minus 6 volts in series with 2 ohms. And here's where the X's are. Y'all hear me okay? Now, you see where these X's are? I'm going to erase that part of the circuit and plug that in there, okay? Y'all hear me? Because this is equivalent to all this. Got me on that? I'm going to do it right here so you can see it. So that's 2 ohms. And in series with 6 volts. Okay? And again, I didn't touch that. Remember? I left that alone. I don't want to touch that. That doesn't do it. That's the last thing I do is figure the current through this wire right here. Now, I'm going to do the same over here. See if you all get me on this one. This is a great question because it really exemplifies how to do these things. You all see how this can become 3 amps going up in parallel with 2? It is 2 ohms in your book, isn't it? This is 3? I'm sorry, 3 ohms. Oh, is this 3 ohms?
Yeah.
My bad. All right. So I should say it would be 2 amps, right? Because it would be 6 volts over 3 ohms. There's 6 volts over 3 ohms in parallel with 3 ohms. Do y'all agree with that? I'll just put it right there so you can see. So this is going to be the 3 ohms comes here. And then I have 2 amps. Don't I, class? Y'all see what I did and why I did, right? I'll take a second, make sure you do. 6 by 3 is 2, right? And then I put the 3 ohms, the parallel is 6. Now, not the front row guys, or second front, not this bunch. Somebody in the back, what's my next step? Not you guys. Yeah.
Combine the two resistors in parallel.
And they would be, right, the 2 ohms. Do you all see the 6 and 3 would be 2 ohms, replaced by a single. You with me, everyone? Okay. Now, I'll tell you where I'm going. I want a single series circuit, so it'll be very obvious to see what the current is. Do y'all follow me? So what's my final step? Take this and make it a voltage source in series with 2 ohms, right? What's the voltage source?
4 volts.
2 times 2 is 4 volts in series with 2 ohms. Absolutely. Remember, the positive is up, right? Right? Correct, class? Now, at this point, I want to make sure everybody sees. This is the way I'm doing it. There are many paths that lead to the right answer, but I try to do things. If I can use source transforms, I do it. It's easy for me. And also, now I can clearly see I'm after that current, right? Now take a look at this. We can just say some of the voltages around the closed loop is 0 and solve for it, but just look here. You see how you have 6 volts driving current clockwise? And you have 4 volts opposing that, don't you? Isn't it the same thing as adding this and getting a plus to minus 2 volt source there? Right? If I have 6 trying to go clockwise, 4 trying to go clockwise, it's like 2 trying to go clockwise. Yeah, clockwise. Do you all agree with that, class? Can you all see, you understand what I'm doing? So I'm just going to take this, erase it, make it a short, and make this 2 volts. And again, I've done that by adding correctly the voltage sources, and the 6 volt dominates the 4. Do you all agree with that? Now, if you look at this, I want that current. How many see what it is? You don't have to give the answer, right? What is it? Well, it's just going to be, I can combine this 2 ohm with 2 ohm and a 4 ohm, right? You agree with that, everyone? They're in series, sure. I can make it one 4 ohm resistor, and therefore this current I here through the inductor for t less than 0 would be 2 volts over 4 ohms, or 1/2 of an amp, correct? Who asked me about this one again? Is this answering your questions?
Yeah, when I did it on the homework, instead of going back into to voltage sources, I kept it in parallel.
You can do that too.
But when I did it, I added the currents up because they were both pointing up. I got 5, and so I got 5 over 2.
No, but the thing about it is, wasn't the current on this, if you look at this, well, I gotta be careful. Do y'all see, this was what? That's 3 amps going up, right?
Yeah.
Then you had 4 in parallel with 4 is 2, right? So then you had what? 2 and times 3 is 6 volts, right? I mean, how did you do it then? Then you get a voltage source in series with that, right?
I did everything you did up until the point where you made them voltage sources and summed them. I had like 3 amps up parallel.
What you did is this. Just give me a second, class. He's saying I had 3 amps here in parallel with 4, in parallel with 4, and here is the thing that's straight through, and over here you had an equivalent of 2 in parallel with, let's see, hold on for a second, then this is going to be 2 going up and 3 and 6 in parallel, right?
Yeah.
Right? But we want this current, don't we? Isn't that right? Now, look here. This is 2. Right? This is 2. Right? Pardon? Okay. Now, you you've got a total of 5 amps going up here, right? But what don't you know? You don't know the split on this, all right? I know where you're going. You could say, well, if I want the current coming this way, you can do it that way, I think. If I want this current, since there's 2 resistors, 5 amps going into both of them, what would I do? If I want this current, I'll call it I, oh boy, here's the problem with this. See, I've got 2 going this way, I'm gonna have a certain amount down. What I want is the current flowing in this direction, don't I? I'm trying to say this in a way that's gonna be, let me do it this way. This is way easier to see. That's like a straight, this is a constant conductor, right? It's the same, yes, miss?
Could you combine the parallel resistors after you do 5 amps and then do a voltage?
Yeah, well, I'm gonna do that right now for him, but I think I know what you did differently. If you get 2 in parallel at 2, that's 1, right?
Yeah.
Now, the only thing I want is the voltage here. That's my goal. Just the voltage. It's the same on this side or this side of the inductor, okay? So if I get 1 ohm, I have 5 amps going through it. Do you agree with me?
Yeah.
If I have 5 amps going through that, 1 ohm, I have 5 volts, right? It means there's a plus to minus 5 volts here, correct? If there's 5 volts here, then the current through here would be 5 over 2 amps. Hold it for 1 second.
What about the other 2 resistors you got up there?
I'm sorry?
Aren't there 2 resistors that you're not accounting for on that right side? Or no?
Well,
Have you
I'm
already
trying to do
sold
this,
one?
I think I know what you did, but you're gonna get the wrong answer, and I'm trying to figure out exactly why. Hold on for 1 second. What you're doing is
Five
right.
over 2, the answer was 1/2.
It should be 1/2, but I'm trying to, let me just work here for a second, all right? The way you're doing, because I think I didn't account for a resistor. What you're saying is I didn't account. This is 3 and 6 right here, so it's 2 amps in parallel with 3. Let me work from there. I think you're right, I think I did mess it up. So this is gonna be 3, and then 2 amps up, right? Correct? Now if I do that, I want that, that's still legit. This is 2. Here, that's gonna be 3 amps up in parallel with 2.
Yeah, that's what I got.
You know what the problem is this? The current through here is not, look, we solved for this current. We got the voltage is plus to minus 5. Here's the deal. The current through here will be 5/2 of an amp, right?
Yeah.
But we want the current through here, right? Isn't it? We want this current coming right through here, right? Well, that's 5/2, right? Coming this way, minus 2, or it's a net 1/2 amp. Follow me on that? This is 1/2 of an amp because you got 2 flowing this way, and you got what, 2.5 going down, don't you? You follow me? You calculate the voltage, there's 5 volts, right? Right? 5 volts by 2 is 2.5 amps going down, right?
How are you getting that 5 volts?
Just- Well, I combined the 2 and 2 is 1 ohm.
Yeah.
1 ohm times 5 amps because you got 3 and 2 going in, right? That's 5 volts, isn't it?
Yeah.
In case you're wondering, here's what we're doing. I take this 2 and this 2 in parallel and make them 1 ohm. All the current goes through that 1 ohm. I'm just looking for the voltage of it. So 1 times 5 is 5 volts. That means there's 5 volts from here to here, right? This is the problem. So if I have 5 volts here, it means it's 2.5 amps flowing this way, right? Now, if 2.5 amps are flowing that way, just follow me on this. Whatever flows into flows out. I've got 2 amps flowing this way, and it requires half amp flowing that way to get 2.5 there, so it's still a half amp.
Okay, so would you recommend just making them, voltage sources in series then? for
Well,
these?
you can do it the way you're talking about, but you have to know what you're after. We're after that current, not this current. And the deception is thinking that current is this current,
Okay, that's what I did.
and it's not. I prefer to put everything in series for you guys, because that makes a lot more sense oftentimes if you see a single series circuit. That's the reason.
Try to keep it in series, it makes it more.
To me, I mean, when I'm explaining to you, that's the way I would do it.
Okay.
Okay, do you all agree with that? It's regardless of what we do, we still get a half an amp for T less than 0. Okay, so IL T less than 0 is 1/2 amp. I appreciate that. Now, getting back to the circuit again, you're going to see something. Both sources are taken out of the circuit for T greater than 0, which makes this problem relatively easy after that point. So we had, this is what the original problem was, 12 volts, 4 ohms. Actually, I think I had to switch here first, but it really won't matter. Then you had 4 ohms. Then you had 4 ohms. Then you had the inductor. Then you had, I think it was 6 ohms, right? And then 3, and then a switch, is that right? And then a battery, or the voltage source here, which was plus to minus 6 volts. That's the original circuit, I believe, and we're after this, right? And we are also after this voltage and this current. Are you with me, everyone? I just redrew it quick. All right, now, follow me on this. When the switches open up, I'm going to go for T greater than 0. I'm just going to erase them to really drive the point home. They're not there. You all see how both of those voltage sources are disconnected because there's no way current can flow through anything from them? You all see that, class? These voltage sources cannot influence anything over this way and that voltage source this way. So what I like to do is just erase them to get them out of your mind because you're looking for a way to use them. Then, furthermore, since that voltage source is out, how much current can flow through the 3 ohms? None. It's gone too. How much current can flow through the 4 ohm? 0, right? It can't. There's nothing, there's no way current can flow. It's an open switch. It's like a closed pipe. Now that's what's left, right? You agree with me? How many, don't answer exact, how many know what the current will be at T equal infinity? Just raise your hand so I get an idea. All right, good chunk of the class. What is it?
0.
Why? You're right.
Sources.
There's nothing to sustain the current, no sources. So now we say IL, as these are the problems that you like. Either if the current at T equals 0 is 0, or the current at T equal infinity is 0, it makes the problem easier. Just like the last quiz you had, the voltage at T equals 0 was 0, and the voltage at T equal infinity was whatever the charging was, right? Anyway, I thought it was that thing again, chirp. Anyway, now after that we need our Thevenin, right? Without me doing any erasing or anything, take a look at this. How many, don't answer with the values. How many see what our Thevenin is just looking at that? What is it?
It's 4 in parallel with 6.
Oh, why'd you say parallel? So, right, erase that. What's the resistance between there and there? You see it's a series connection? Don't worry, make the mistakes now, not during the quiz. This is a good time. If you're gonna get them out, get out your mistakes now. Yeah.
Can you explain how that is a series?
Sure. If you had current flowing through here, you see the same current has to flow through both of those resistors? Series means the same current, anything leaving here can only get back here by going through both of these. You see that?
Yeah.
What is parallel? Well, parallel would be the same voltage, This is a parallel combination, right? Notice the point here, they're parallel with respect to these 2 points. Do y'all see this? Please watch this, right? If I say between these 2 points, is the value? It's R1 in parallel with R2. But if I say, what's the value of the equivalent resistance between those 2 points, now they're in series. Do y'all see that, class? All right, make sure you do, and make your mistakes here. It's a good time, but don't pass it. With your, I don't know if you did that on purpose, but it sure seemed like it. What are they? No. Okay, y'all see this, class? So that's R Thevenin is going to be simply 10 ohms, right? How many see this, by the way, so we can move on? So R Thevenin is 10 ohms. Now, what is tau, class? It's what? L over R Thevenin, right? Let me put down the equation. L over R Thevenin, right? And L is raised. What is it?
2 Henrys.
2 divided by 10, right? So that's 1/5 of a 1/5 second. The units are seconds. Okay? Then you put up the equation. Now we get our IL. IL of t is equal to K1 e to the minus t. Well, it's really 5t, isn't it? Because it's t over tau. Tau is 1/5. Plus K2. Do we need to put K2 down? Why? You're right. It's 0. No current, no problem. It's gone. All right, what is K1? It has to be the current at t equals 0, right? So it's 1/2, right? And I want to make mention of this. In an inductor, current can't change instantly. It has to have some grad. If it did, the voltage would be infinite because the voltage across an inductor is L di dt. If di dt was infinite, the voltage would be infinite. That's not allowed. Y'all follow me on that, class? Just like with a capacitor, the voltage can't change instantly because then the current would be infinite. For an inductor, the current can't change instantly. So the current just before the switch closes is the same just after the switch closes to that inductor. Yeah.
I'm sorry, how did you get the 1/2 again?
Which one?
The 1/2 the E.
The what?
Like,
This?
Yes.
That was the current for t less than 0, was it?
Yeah.
That was the thing he asked me about at the beginning. Okay? With me on this? So that's the equation for the current right here. We've got it, and this is for t greater than 0 or equal to 0. Now, you see how I eliminated everything in that circuit that wasn't part of the t greater than 0 circuit, didn't I? Y'all see that here? Now look, we have an equation for this current. I know right here, this inductor current, IL of t, is designated as this. We know that for all t greater than 0, don't we? Now if you look at that, how many see that current is I naught? Give me a show of hands. Y'all see that? It has to be. It's flowing this way, going down. It is the same current, is it not, class? How many see it, by the way? I want to make sure. Okay. Now, that current's flowing this way. You'll notice they want the voltage plus to minus, right? But this current is entering the negative terminal where they want that voltage, right? Y'all see this in the back, guys? So that means this voltage, V out, will actually be minus IL of t times the resistance, which is 4 ohms. Do you all see that, class? Because what? In the real world, this current would cause a plus to minus voltage, right? But the measurement is done with a plus at the top, minus at the bottom. Do you all see that? Everybody good with that? That's a great question, by the way. I'm glad we made that mistake and that mistake. Yeah.
So then the answer would be negative 2e to the negative 5t for...
Yeah, it would be, and it's probably the right answer. Okay? Next question, a great question. I mean, when you expose likely problems or mistakes, it's the ideal. Go ahead.
VD 3.43.
So is it supposed to rain all day today? All week. I tell you, I drove in today, and I thought, well, I got plenty of time to find, not really plenty, but enough time to find a parking space and get to class in time. What an absolute mistake. When it's rainy, everybody drives in. People that take motorcycles, people that bicycle, people that walk. It took me a long time to find a parking space. And I ended up pseudo running to get to my class. And I was still a minute or two late. So I've learned. All right, which problem number again?
3.43.
Okay. Sorry. All right. So, is there anything else they want? All right, now this was not put in, but I put in the value IL of T, because that's what I'm gonna solve for. Y'all follow me? You're gonna have to write that in there. That's what you care about, then you get everything else. You get the current through that inductor. So I know IL of T equals some K1 e to the minus T over tau plus K2, and tau is equal to L over R Thevenin. Now, back to this thing. When you look at it, all right, just take a look at this for a second before I say anything. Looking at this thing, after the switch changes state, how many can see the current at T equal infinity is 0? Take a good look. Y'all see it? When that switch opens at T equals 0, it disconnects all that stuff from over here, and there is no source left. Y'all see it? So, yes, sir.
If the current arrow was pointing down and you disconnected the switch, would current still be able to get to the conductor?
It won't matter what direction this is. The minute I do this, right? In order for current to flow out, it has to have a way to flow back, right?
Okay.
The minute I open that, it's only connected at one point. It has no influence at all.
Alright, sounds good.
So, like so. All right, now, I take a look at that. You've made the correct observation. How many see that there's going to be no current flowing as T goes to infinity? Let me see your hands again. All right, if you do not see it, then see me. It should be obvious at this point if that switch changes state and there's nothing left, no source left in the remainder of the circuit, it goes to 0. So I'm going to do both of us a favor. I'm going to get rid of that, okay? We'd get rid of it anyway, but I'm just getting rid of it now. Now, after that, for T less than 0, we need that current. And for t less than 0, the switch is closed. So let's draw the circuit. By the way, this is the way I do these problems. Some of you probably by this time will do it. You see that I could simplify this to just 12 ohms? How many see that right there? They're in series, sure. Just make it 12, so I'm going to do that. And now let's see, can I simplify anything else? Well, I'll leave those two alone because ultimately what? I want the voltage across the 6 ohm, the far 6 ohm, right? I'll leave them alone. But take a look at this. Now, if I take a look at this, I've got 12 ohms. Then I've got this, which is 120 milliamps, or 0.12 amps. Then I've got that switch is closed. This is for t less than 0. Then I got 3 ohms. And I have my inductor, and I replace the inductor with a short circuit. And this is what I want, this current IL t less than 0 here. And then I have 6 ohms, and here I'm going to go ahead, because I don't really care about that now. You see the two 6s are in series, I can replace them with 12, class? How many see that? You see it okay, guys? Sure. This and this are in series, 12 ohms. But I want this current, right? Now remember, you can get this current any darn way you feel. I try to do it the easiest way with source transforms whenever possible, and just use current division problem. Now, can you all see here? If I want that current, just listen now. If I could just have that resistor in parallel with another resistor, all those resistors are in parallel. How many see that? Y'all see it? They're all in parallel, right? Same voltage across every one. So what I'm going to do here is take the 12 and 12 and make it an equivalent 6 ohm. How many see that? Can you see it? You guys see it? And over here, you guys see it? Right? I got 12 and 12. They're in parallel. I know one's here and one's there, but they're electrically in parallel. I'll make one of them 6. Get rid of that. Just make this 6. Now, look, you can see the way I'm doing this. When I look here, if I want this current, these two are in parallel, right? A net current of 120 milliamps is flowing into the parallel combination of those two, isn't it, class? So if I want the current, and there's 2 ways to do it, 3 ways, but they're all equivalent. What I can do is say I can get the equivalent resistance, and that would be 2 ohms, and I multiply it by 120 milliamps. I get 0.24 volts, right? And then I can divide 0.24 volts by 3 ohms to get that current. That's one way. Y'all follow me? I'm just getting an equivalent resistance to get the equivalent voltage, then dividing the voltage by the resistance to get the current. Or the easy way, which is the same thing, is just take the net current and do current division. You with me on this, class? Either one would do it. So if I want the current here, right here, IL for t less than 0, it would be the total current, 120 milliamps times the opposite resistance, 6, over the sum of the two, or 9, or it's 2/3 of 120 milliamps, right? So that's going to be 80 milliamps, right? So now I've got the current at t less than 0. Right? Are you with me? How many see this right? This isn't hard, but you have to make sure you're attentive here. Now the next thing I'm going to do is let the switch do its thing, okay? Now we go for t greater than 0. I want to make sure everybody's on the same page. You good with me, class? All right? So when the switch does its thing, doesn't it effectively get rid of all that? Right? So I'm going to get rid of all that because it disconnects it. It's only connected at one point, therefore it is disconnected. That's what's left, isn't it, class? Take a good look at this. Now, for this, just look at it. What would R Thevenin be? Just think about it, and why?
15 to 1.
what do I really wanna do? If I wanted to do this exact, I would remove that and draw a little circle here and here and say, what's the Thevenin equivalent resistance across those 2 points, right? So if I'd measure this, y'all see that these are in series class? So I've got what, 12 and 3 or 15 ohms, don't I? How many see that? 15 ohms. And therefore, tau would be L. L is 0.6 over 15. What is that? Oh, gosh.
0.04.
Right. Seconds. 4/100ths of a second, right? Agrees, class? And then I have the equation, because I know that K1 has to be the current at T equals 0, and I know IL of T is 80 milliamps. If you want to write it, you can just put 0.0, 80 milliamps is going to be 0.8 amps, or 8/100ths of an amp, and then it's going to be times e to the minus t over that, and I can just put 0.04 if I want. And this would be the current in amps for t greater than 0 flowing through that inductor. I'm going to draw the inductor in here. And I call that current, I have it going from top to bottom, don't I, class? Now that's the current. Do you all agree with that, first of all? Take a good look, right? If that's the current, then what would the voltage be here? Now, the current's going this way, right? Counterclockwise, correct, class? So a voltage would be developed plus to minus, that would be this voltage, I'll call it V prime of t, would be simply 6 times IL of t. Y'all follow me? That's where the current would be entering the positive terminal. But the measurement has the positive on top, so actually V out of t, the polarities are changed, would just be minus that, which would be minus IL of t times 6, or it would be minus 6 times 0.08 e to the minus t over 0.04, and this would be for t greater than 0. The units would be volts too. Y'all follow me on that, class? That's the only thing different, is that you gotta make sure you get the minus sign. I mean, just be wary of that. Agree? Okay, another question. You got one. We didn't do one with a source left. That's the thing I thought you'd come. Let's see here. 245 has a source left, doesn't it, class? It's a good problem. I mean, they're all these problems, if you go through them methodically, they all become very obvious. But you have to do a fair number to develop your confidence in this stuff. So, 3.45, I said 2 didn't I? 3.45 is kind of interesting. And they got stuff in here that, well, not too bad actually. Well, they just want the current through that inductor for t greater than 0. So they want I L of t, and we know it'll be of the form of k1 e to the minus t over tau plus k2, right? We know that's the form. Now this one's interesting. That's 4 volts right there. The reason it's interesting is what? When that switch changes state, there's still 4 volts left to drive current. Y'all see that? Take a good look at it just for a second. Convince yourself first that it doesn't go to 0. All right. Now, I always start at t less than 0. So I want IL for t less than 0. How would we do it? How would you do it? Ask yourself that now before I just show you. Don't always look at the solutions. Struggle with these things. If you struggle, and then see if you get the right answer, you'll be all right in the quizzes. When you just look at the solutions or talk to friends on how to do it, you're hurting yourself, in my opinion. You want to go at this thing without any. You more or less want to do this as if it was your quiz when you do homework. Yeah.
Can you do source transform to make all this?
Oh, absolutely. And what I would do is redraw the circuit for t less than 0, but you're absolutely right. So for t less than 0, he's right about this. And can y'all follow me on this? T less than 0. You see how I can make this just 6, or make it 3 amps in parallel with 2 ohms? How many can see that? So I'll make that 3 amps in parallel with 2 ohms. That takes care of these two. You said that, sir, so I'm going to keep going. Can I put a 6 there then? Sure. Right? That's this. That switch is closed. You'll notice right next to it is what? An inductor, correct? And that inductor is a short circuit, right, class? That's a short circuit, and that is what I want, actually, the current through that. And then you have to move that 6 over here. Then I'm gonna, if you don't mind, y'all follow me what I'm doing so far? Give me a show of hands if you do. All right, y'all see right here, I'm gonna continue with the source transform, and the only thing I'm gonna do here is make that 1 amp up in parallel with 4. Do y'all see that? So, then over here, I just leave this as IL. I have 4 here, right? And then I have 1 amp. Take a look, make sure you agree with my assessment of the situation. Y'all with me? Now, in the book, there wasn't a resistor in front of that, I don't think, unless I don't see it. Or in that. No, there isn't, which makes this problem really kind of unique but good. Now look here. I want you to just notice this. You see how you got a direct short here? Can everybody see that? I mean, really emphasize. That's just a straight wire. In parallel with all this stuff, who cares? All this current will go straight through there. That 3 amps will go there. And this 1 amp will go there. So it'll be a total of 4 amps. How many see that? The reason is that wire is in parallel with these resistances. So if you take 4 in parallel with 6 in parallel with 2, it comes down to something finite, right? Anything finite in parallel with a short is still a short circuit in value. And that means there's no voltage difference from here to here. And it means all the current goes down that short. How many see this, class? Now that's important because people make mistakes. Here's one of the things I believe happens. People say, oh, it must not be that because we never covered that in class. I promise you, people think this way. They try to reason themselves into the wrong answer, and they're good at it. They can convince themselves to go down the wrong, a wrong set of reasons for it. Just do what you know is right. If you have a 0 resistance in parallel with any resistance, everything flows to the 0 resistance. That's it. It's the path of least resistance. So that means here that it's 3 amps and 1 amp is 4 amps, right? Are you with me? Just bear with me. Now let's get the current IL as t goes to infinity. I know I'm overtime, but just hang with me, all right? Class, I'm going to let the switch change states. Y'all hear me on this? Now the switch opens, and it disconnects all of this, doesn't it, class? Y'all see that? So when it disconnects all this, this is what remains for t greater than 0. Isn't that right? Now look at that. What is the current through here going to be as t goes to infinity? Can anybody tell me without me doing anything more? How many believe it's 1 amp? Great. Yes, you can do a source transform, but if that's a short circuit, just take 4 volts by 4 ohms is 1 amp. Sure, it's 1 amp. Now, what is R Thevenin for this? This one you better not blow. What do you do with that voltage source? And don't say cut it out. What do we do with it? Short circuit. I was wondering, why was he saying that? Because I can see people cutting it out. Oh, the resistance is infinite. No, it's a short circuit, right? This is a Thevenin equivalent resistance between us. So that means R Thevenin is 4 ohms. Tau would be L over R Thevenin. What was L for 2? So it's 2 over 4, or 1/2. Can you all get the rest of it, guys? Or not? Now listen, here's the trick, the only trick left. You've got the current is t equal infinity 1 here. So you have 1 equal K1 e to the minus t over tau equals this. The way you get K1 is you put the current at t less than or equal to 0, which you calculate as 4. Let t equal 0. Solve for K1. Done. How many see this right here? Okay. I don't mean to bore you with these things, but trust me, if I don't go through these methodically a couple of times, especially with the help of you guys, because those mistakes help. People mess it up. I'll see you Friday. This is what the quiz is on. Transients.